Welcome to this discussion on converting term bases that we use in translation applications and translation environment tools to knowledge graphs that we would use in integrating them with natural language processing tasks. During this discussion, we're going to be following along with this resource, converting term bases used in translation into knowledge graphs used in NLP tasks. We're going to start with a problem statement. Next, we're going to do some review of the theory of term-based data modeling. We'll look at an example term-based data model, the LocTerms project. After that, we'll look at how can terminological data be modeled in the knowledge graph environment. We'll take a look at the knowledge graph model that I've created for the LocTerms project, and then we'll get into some conclusions. So let's start with our problem statement. We're trying to convert a term base to a knowledge graph, and we need to map the standards-based data model for term bases to a knowledge graph data model that facilitates natural language processing tasks. So when I say a standards-based data model for term bases, what I'm talking about is a data model that's based on standards like ISO 704, terminology work and methods, and ISO 30042. That's the standard on Termbase exchange, and Termbase exchange is the file format that underlies term bases that are integrated with computer-assisted translation environments. So when we start talking about knowledge graphs, first we need to understand, and specifically knowledge graphs that are being designed for terminological purposes. First, we need to understand some of the fundamental theory behind terminology work. And so this first section, in fact, the first couple of sections of this discussion, of this recording that I'm currently making. This is a review of content that's covered in the LOC 501 Terminology for Beginners course. So if you're enrolled in that course and taking that course, you have access to topics that contain a lot of information on the topics of standards in terminology work. Even though you have access to this information within the course contents, and if you don't, obviously we need to cover it a little bit here, but even if you do have access to this information in your course contents, going through and doing a review of this content never hurts, right? It usually takes us around 6 or 7 times encountering information before it starts to become just ingrained in our sort of mental processes and things like that. And so going over this content again isn't going to hurt anything. So we're going to start by looking at, first of all, what's the difference between lexicography and terminography? Lexicography is dictionary work, right? So in dictionary work, we're taking a word and we're collecting all possible meanings for that word into a word entry. In terminology work, we're doing the exact opposite of what happens during dictionary work. So we're starting with the concept. We're essentially starting with the meaning. And from there, we're collecting every single name that denotes that concept. Now, this helps in translation tasks and in content generation tasks because it's helpful for translators to know what's the concept I'm translating here. Translation is a sense for sense-based task. We're trying to connect meaning to meaning. It's not just simply doing I'm going to switch this word in for another word in another language. Not at all. It's about finding what are the designations that go together that underneath them, they represent the same concept, the same idea. And so that is a fundamental aspect of terminology work that we need to keep in mind, not only when designing term bases, but also when designing knowledge graphs that are based on terminological data. Now, it merits revising as well the hierarchy of a term-based data model, because we need to understand first the data model that we're going from. For taking a term base to a knowledge graph, we need to understand where we're starting, what's the model we're starting with. And in order to be able to design the model that we're going to take what we have and redesign it into, reconfigure it into. So to review once again, within Termbases, information is collected at the concept level, the language level, and the term level. The concept level happens only once within a concept entry in a term base. The concept level in a concept entry collects the information that applies to all the rest of the information in the entry. So one of the most important pieces of information we can collect at the concept level within a terminological entry is the subject field, because the subject field is an important piece of context that is going to give the entire concept entry its meaning. We'll have as many language levels in our term base as there are languages in the term base. So in this term base, you can see 2 language levels, or in this illustration on screen here, we have 2 language levels because there's 2 languages in our term base. And then underneath the language level, there's going to be the term level where term blocks are housed. And the term blocks are the part of the concept entry that just says, hey, this is one of the names that is given for this entire concept. When thinking about how we model the information in our term base, other important pieces of information to include at the concept level that's often overlooked is information about concept mapping, how the concept relates to other concepts within the term base. Within terminology work, to do concept mapping, what we're essentially doing is determining, okay, I have this concept. Is it a type of or a part of something else? And if it is, then I'm going to denote that in the concept entry. Or for the concept entry that I'm working on, are there types of or parts of this concept entry within my term base? In that case, I'm going to include that in the concept entry under related concept broader or related concept narrower data categories. We'll talk a little bit more about data categories in a bit. But essentially, let's say I'm working, and I'm going to use some terminology that's almost from general language now, but let's say I have a concept entry for a computer, and then within my term base, I also have concept entries for keyboard, mouse, console, et cetera, et cetera. Each of those parts of the computer would be listed in my concept entry at the concept level for a computer as parts of a computer. And this again just takes the term base and turns it into a much more robust and applicable resource, because not only are we learning what concepts are from within the term base, we're also learning about the entire model of knowledge that underlies the concept entries within the term base. So that's really important for terminology work. When we get to knowledge graphs, you're going to see that essentially concept mapping is a central part of a knowledge graph. You can't have a knowledge graph if it's not modeling concept relations. And so it's kind of nice that that's a required piece of the knowledge graph, where it's an often overlooked part of term bases. When we're looking at incorporating data categories into standards-based data models, there's a few resources that are available to help guide our work when we're thinking about what's the data model that I'm going to use in a database. What fields or data categories am I going to include at each level of the term-based structure? Well, there's guidance on that, right? You can take a look at ISO 3004 that I mentioned earlier. There's an entire website by the folks who have written the ISO 3004 standard, this TBX info that talks about different variants or different versions of TBX compliant data models for term bases. There's the DatCat info site. This is a site that leads to a repository of thousands of data categories that could be included within the data model for a term base. So these are all great resources that can if followed, can help us to ensure that our term-based data model is something that meets standards of best practice. And there's also this handout, the side-by-side comparison handout. This looks at different what are called dialects of TBX that are compliant with standards. Dr. Suellen Wright wrote a paper on that. And this document gives more information on the types of data categories that we might include at each level of a term base. So let's take a look at an example data model. Let's say that we're working with a term base in real life for a real life use case. What might a data model look like for the term base? And for the purposes of this, we're going to look at the LocTerms project. So we'll be working on this. This is essentially a project that I started that collects localization terminology, terminology related to translation and localization into a term base. It collects corpora and things of that nature related to translation and localization. And we've designed a glossary structure, or I've designed a glossary structure that I discuss in more detail on this page. But the too long didn't read version of the data model is that within this project, and I should mention first before I get into the data model that this is a data model designed for a field of scientific practice, So this data model has not been designed for use in a company, for example. If the company wanted to create a term base of their terminology that they use for their products, for their brand, et cetera, that would be a different data structure. The data structure that I'm using here has been designed based on my specific ideas about what I want my project to accomplish, but first and foremost on the fact that I'm working with a specialized domain. I'm working with terminology that is not going to change no matter the company that uses the terminology. Any company that works within the domains of translation and localization is going to use the same terminology. And so this is scientific terminology here, and the data model has been designed for those purposes or that purpose. So at the concept level, I've got a status pick list, whether the concept entry is new, covered, semi-validated, or validated. I've got a subfield pick list. I don't have a subject field pick list yet because the subject field of translation and localization is assumed. Right now, I'm working on actually expanding this section so that it includes a subject field. And essentially, the subject field would be one that is within the even broader area of translation and localization. And then I would have more expanded subfields for each of the subject fields, but I'm not quite ready to share that yet. It's still in development. So yeah, in the future, it's coming. I've got a field at the concept level for the superordinate concept. So that would be the broader concept, and the subordinate concept, that would be the narrower concept. Again, if we're thinking about generative and partitive concept relations, if I'm working with a computer, that's the superordinate concept, and then the parts of a computer would be the subordinate concept. So depending on what entry I'm dealing with here, I might want to include some concepts at these data categories. And then I'm keeping a note field at every single level, just because that's a best practice of term-based design, is just allowing for there to be notes at every level of the term base. At the language level, I'm having a definition and a definition citation, and then the language notes. At the term level, I've got a variance pick list. I'm working with English and Spanish in this term base, where the variants can be international, United States, Latin America, Mexico, Argentina, Spain, or other. And then as terms get added, and let's say I suddenly have quite a few terms in Colombia, and then I would add those to the pick list. And yeah. I've got a Boolean to indicate whether the term is the head term or not. Remember, we're collecting all of the designations for a concept in a single entry. And so I'll want to indicate which of the terms collected is the head term, the term that's used most frequently by subject matter experts in the field when they're talking to other or writing for other subject matter experts. I've got a usage pick list where I'm indicating whether the term is preferred, allowed, not recommended, do not use, or deprecated. There's a context field, a context citation field, and then, of course, the term note field. How do contexts and definitions differ? The definition, if it's intentional, will list for generic relationships at least, will list this concept is a type of this, and this concept has these delimiting characteristics that differentiate it from other coordinate concepts, from sister, sibling concepts, to the superordinate concept. Context, on the other hand, a lot could be said about context, but it's essentially the term exactly as it's spelled in the term block, used in context. So having a lot of contexts built up, I think, can be a great resource when integrating terminological data with large language model applications, where examples are what allow the generative AI applications built on LLMs to really perform. So if you want more information on contexts, let me know, and I can share a whole bunch of resources on that. So here's an example concept entry from the LocTerms Termbase. We've got a subject field of general. At the language level for English, we've got our English definition. This is for a concept that has the terms localization, L10N, and loc. So I've got my 3 term blocks. These are all designations that are used to name this concept of customizing the non-textual or design aspects of language services and products. At the Spanish level, I've got the definition, I've got the term, and yeah, so this is an example term. And if you're interested in seeing multiple concepts modeled according to the data model, this is an export, a small selection of an export of a SmartCat glossary. SmartCat is a computer-assisted translation tool, and this is a small selection of a glossary that has been exported from SmartCat. So you can just see, I mean, there's columns upon columns upon columns of information here, because every time there's a new term block that duplicates a set of columns, the set of data categories that are being collected about terms. So later on, we'll see, okay, how do we take like a database like this one that is just huge, it's got all of these columns, and how do we reconfigure it in order to import it into a knowledge graph environment? This is the new subject fields that I'm working on. The new, before I had that basic subject field and subfield list. And so now this is the new model that I'm working on. So now let's move on to modeling terminological data in knowledge graphs. So essentially, when we're working with a knowledge graph, first we need a definition. What is it? It's a type of a semantic network. So if I try to name the superordinate concept, if I'm trying to write an intentional definition, intentional not spelled like intent, when somebody has the intent to do something, intentional spelled intentional, intentional definition is a definition that names the superordinate concept and then the delimiting characteristics that make a concept a concept. So our superordinate concept here is a semantic network. A semantic network is a structured knowledge representation that represents real world concepts and objects as entities and relationships. When we're looking at knowledge graphs, next we need to know what are the delimiting characteristics so they can be distinguished from other types of semantic networks, in that they are designed specifically for computational reasoning and have the ability to handle much larger volumes of data. They are known for the use of rigorous formal specifications like RDF, more complex property types being associated with the nodes and edges, and more sophisticated mechanisms for querying and inferencing. There's this really great article with a video that Google has. Google popularized the concept of knowledge graphs with its implementation of them at a massive scale for web searches back in 2012. So they they did this announcement with the tagline "Things Not Strings," which is a tagline that I absolutely love, because I'm often talking about the fact that, translation isn't the act of converting, of taking words and replacing them with other words. It's not just strings, it's actually concepts behind things. No, it's the things, it's not the words, it's the things, it's the concepts, not the words. And so they announced their knowledge graph powered searches that could distinguish among concepts denoted by the same designation. It's a very cool article and very cool video as well that I think gives a great beginner understanding of what knowledge graphs are. So I would encourage you to watch that video if you are unfamiliar with knowledge graphs. So just to continue our definition, knowledge graphs, now this would be more of a definition for a partitive set of relationships. Partitive relationships are where we look at, okay, defining a thing according to its parts, right? And so knowledge graphs have these kinds of parts. They have nodes and edges. Both nodes and edges can have properties associated with them. Nodes can have labels. Edges are directional. That is, an edge can be symmetric, where the relationship goes both ways, or asymmetric, where the relationship goes only one way. And for the purposes of my work here, I'm working with Neo4j. It's a graph database management system. And the data elements are stored, as we heard, by nodes, edges connecting them, and attributes of nodes and edges. You've got some further reading here you can do if you'd like to learn more about knowledge graphs. So now let's think about actually going through and taking our term-based model and converting it to a knowledge graph. The first thing that we want to do is we want to create some nodes. This would be a node. The line would be a edge or a relationship. So I want to create nodes for the concept, and I also want to create nodes for each of the terms that denote the concept. And here I immediately run into issues, because we run into the same problem within knowledge graphs that we have in all of terminology, right? Going back to the semantic triangle, which is a fundamental theory of knowledge representation, the semantic triangle essentially says that the world is made up of objects, which is anything that is perceived or conceived. Those objects are abstracted into the human mind as concepts, and then those concepts are named in human language through designations, through terms. So we've got these three different pieces here. However, as humans, we only have the language available to us to talk about any of it, right? So I may be wanting to talk to you about the object, but I have to use the name for the object in order to name it, in order to have that conversation with you. If I want to talk about the concept, the abstraction in my mind, I only have the designation available. And so within the knowledge graph, I have the same issue. What do I name the concept if I only have the terms, the designations available to me to talk about what it is that I'm talking about? So there's a few different options that I can go for here when I'm thinking about what is the primary unique label that I'm going to give for the nodes that represent concepts. And the nodes have to have a unique label associated with them. I can use something like a concept ID. The issue here is if I'm using a concept ID, for me, immediately as a terminologist, I think about the fact that when we're building out a term base, what we want to do is we want to order the concepts we're adding to the term base logically, right? And so I wouldn't add the concept computer-assisted translation before adding the concept translation, right? I want the base concept first with a definition for the base concept, because that's what's going to give a later concept like computer-assisted translation its meaning, which implies an order, right? It implies the order that, at least if I'm only going to have two concept entries, that translation should be the first concept entry and computer-assisted translation should be the second concept entry. When we think about this ordering too, logically, we think about number by number ordering, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But that's not how term bases work either. I mean, it is how term bases work. There's a concept ID associated with every concept added to a term base that is based upon the order in which it's added. But that's not how concepts in real life work, right? It's more like a tree format where maybe I have translation as the base, and then I have under types of translation, then I have computer assisted translation, machine translation, conventional human translation, and then each of those form branches off which a whole bunch of other concepts are built. And so numbering that, figuring out a numbering system for something like that poses challenges. Next, I could use an abbreviated definition, right? So essentially, if we're thinking about, okay, what could I name this concept node? Maybe the abbreviated definition would work. Here's the issue though. Term, a designation in and of itself, is an abbreviated definition for the concept. Essentially, the designation is a short form of the definition, and the definition is the long form of whatever the concept is. And so a designation is really just meant to be a label that pulls to mind the ideas, the definition of what the concept is. So it doesn't make sense that I would include an abbreviated definition. On the other hand, maybe I can use the head term. Remember, the head term is something that's the most frequently used term for a concept used by SMEs addressing other SMEs. However, this one is a tricky solution as well, because let's say I'm working with the concept that I have to name right now as localization, even though the word localization is not the abstraction in my mind of what this is. But essentially, we've got the term localization that can denote the concept of adapting services and products to new language markets. That's one concept denoted by the word localization. Another concept denoted by the word localization is the act of customizing linguistic conventions in textual content to match those in use in the target language. That's another concept that's denoted by the word localization. Yet another concept denoted by the word localization is the product of adapting a product or service. So there's many different concepts that are all denoted by this idea of localization, and each one of those needs to have its own name for the concept node within our knowledge system. I can't keep using localization over and over and over. I'll show you right now what I've done to resolve that. Is I essentially I've just numbered the name of the concept. So I've got localization 1 with my definition that tells me which concept this is, localization 2 with my definition that tells me which concept this is, localization 3, which gives me the definition to tell me which concept exactly I'm referring to. And so this is the Neo4j environment. We'll take a look at this in a little bit more detail in a little bit. So that's the solution I came up with. When naming the nodes for terms, the solution that I've come up with is also doing the concepts with a capital C. So it's like the big idea. It's got the capital letter, but then the terms are lowercase. So the terms, and this follows terminological practice, where we would want the term denoting a concept. In this case, we've got 3 term nodes in here for the various concepts of localization. One is a colloquial form, one is an abbreviation, and one is the full form. Those are all listed in lowercase, as is the label, because terms are listed in a term base in lowercase unless they are proper nouns, because otherwise it's confusing to everyone. It's like if you list a term in the uppercase, suddenly people wonder, am I supposed to put this in uppercase all of the time in writing? It's just not clear. Other aspects of the term or the knowledge graph structure that require careful consideration include, what are we going to do with language families and variants and subject fields and subfields? And this is where we get a pretty unique opportunity within the knowledge graph environment. But essentially what I'm wondering here is, for language families and variants and subject fields and subfields, do I represent these as labels or as nodes within my knowledge graph environment? So if we go over here, this is the label. This orange, yellowish colored item right here is the label. And I can have multiple labels associated with a node, but I have to have at least one label. So my idea with this map is that we've got a pretty unique opportunity here. What normally happens in Termbases is that, as you previously saw, all of the concepts and all of the names for concepts, no matter the language, are collected into a single Termbase. So you get a concept entry and it's got all of the terms that denote that concept in whatever language collected into the concept entry. Now, why is that problematic? Well, because what typically happens there is that an assumption is made. An assumption is made is that terminology work is a process of translation. So typically a lingua franca like English is taken as the source language, and all of the languages of the Termbase are taken as target languages, even though that's not the way that terminology work works. What happens under the structure then is that, let's say we'll get a definition, we'll be indicating superordinate and subordinate concepts. All of this comes from English or whatever lingua franca we're working with. And then that conceptual structure is being imposed upon all of the other languages of the Termbase, even if it doesn't fit the other languages of the Termbase. And I know this happens. I know I'm not the only one who knows that this is happening, that acknowledges that this is happening, because Carol Warburton, for example, talks about the fact a lot that terminology work isn't a process of translation. It's in fact building up the concept maps in each of the languages and then deciding which terms can get, or which concepts can get connected together, which ones are true, truly correspond. I've talked to terminologists at one of the largest terminology organizations, or the best known terminology organizations in the world. And that person even acknowledged to me that, yeah, when I'm doing my terminology work, I have to try to make the other languages fit into the structure of the English language, because the English language is assumed as the essentially lingua franca source language of that Termbase. So it happens. And with knowledge graphs, I think we have a unique opportunity to not do that, to essentially have our concepts in English, have our concepts in other languages. So let's say I wanted to add a concept in another language. Right now, I only have concepts in English, so I'm going to do a merge. Let me go get I still do not have these memorized. Let me go get my theory language down here, where I'm going to now add a concept in another language into my workspace here. So I'm going to add my concept. This time I'm going to add traducción. Well, we're going to go merge. So let's go ahead and add that. Let's also add and now we're going to indicate that this term, this concept comes from this language. So we're going to go match. We'll get my code over here. Because I just want to, here I'm creating a relationship. So I'm going to say C is from C. Label I used for that is from language family L. So now if I go back over to my model. Actually, that should have been language family. But anyways, you can see now I have this concept traducción that's added, and I can connect this to translation. I can say that these correspond. Let's go add. But we're going to create a symmetric relationship. I think that's how I do that. Let's try it. Okay, I'm just going to see what's the cipher for this. Ah, look at that. We have to go both ways. Okay, so now when I go to explore, now you can see we've got this two-way relationship right here, where translation corresponds to traducción y traducción corresponds to translation. I think there should be a way that I should be able to have a single line there. I'll have to look that up later. I showed that because I think we have an opportunity to let the concept models from each language exist within themselves in a knowledge graph, and then only connect together the concepts from different languages that actually correspond to one another. I really like this idea because concepts are highly contextual. A concept is defined according to its context, and that context includes the language that it comes from. And so taking and saying, I'm not going to just have a single concept entry and put all of the languages within that concept entry, which assumes that all languages follow the same model. But instead, I'm going to add concepts to my knowledge graph in each language, add the terms that denote the concepts in each language, and then connect together only those concepts that correspond to one another. I think that's a better approach. When thinking about doing that, we need to think about what kind of name we're going to give for that relationship. So, you know, when I was trying to figure out what label to attach to that, I landed on corresponds to. Some of the other alternatives that I thought of included is translation of, which I ultimately determined to be inadequate because the concepts aren't a translation of one another. The concepts exist in their own right as they are derived from each language. I thought about putting is equivalent to, but I really do not like the use of the term equivalent in translation, because in my mind, the word equivalent gives the impression that the context is the same, which it's not. Anytime I'm using a word in any language, for the people who are hearing me use that word or hearing me deliver speech, they're drawing upon an entire context of previous knowledge to understand what I mean when I use that word. And part of that context is the language. Part of that context is the culture from which the language is derived. You know, it's the region, it's the systems in place. And so equivalent, no, language systems aren't equivalent by any stretch of the word. And so corresponds to seems to me the safest way to name that relationship. In any case, going back to this idea of, you know, where do we put the language families? Where do we put the subject fields and the subfields? Do we represent those as labels that are getting added to a node, or do we represent those as nodes in their own right and then connect all of the concepts that and terms that are in that should be connected to those nodes? Do we do it that way? At this point, I've decided to create separate nodes for language and families and variants and subject fields and subfields, and to connect concepts and terms to these nodes. I've done that because it allows more flexibility in letting the graph model grow over time. It might be that eventually I need to add properties to my language families and language variants. It also helps to limit the computing power that's needed to process queries when looking at a knowledge graph. If I use a label, then every single node needs to be checked to make sure whether or not it corresponds to that specific label. If I use a node and write a query, I can just simply direct the query to that like language node, for example, and then to find all of the concepts or all of the terms that are attached to that language node. Some other nodes that I've considered adding at some point, I'm thinking about adding, are different types of audience node, where I would have audience groups and audience types. Because essentially when we're choosing what terminology to use, when different designations are available to us for naming a concept, we'll pick a different designation based on who we're talking to, right? And often that's sort of the deciding factor on what's the term I'm going to use. Am I going to use the scientific term because I'm talking to another subject matter expert and I want to present myself as a smart person? Or am I talking to someone who doesn't have the same technical knowledge as me? And so I don't want to sound like egotistical or something by using the scientific names that are just going to confuse. And instead, I'd like to use a simpler designation that's going to aid in understanding. So I think including audience labels or nodes could really help in natural language processing applications, could help the generative AI systems to select specifically which label to use given the context, given the audience of the whatever content is being generated. When thinking about relationships within the knowledge graph, so now you can see I've got my nodes for my terms, for my concept, and then here's a relationship. Is designation for? We've already looked a little bit at relationships. Here are the relationships that I'm using in my knowledge graph. I have relationships that connect language variants to the language family. These ones I'm still really working out. Any of the relationships and the nodes related to the language family and the language variant, I'm still thinking carefully about because I'm not sure what's the best way to model that information and to connect terms and concepts to languages, essentially. Thinking about like the language family or the language variants. Do concepts come from language families or do they come from language variants? I think they can come from both. Are designations within a language family or in a language variant? They can come from both, right? And so I think it's just going to take some application for me to see if I like the relationships that I have. I'm also getting a little bit more precision with my concept mapping through relationships within this knowledge graph system. Previously, in my Termbase, just for simplicity's sake, I was listing superordinate concepts and subordinate concepts within the Termbase entry, not keeping in mind at all if it was a generic relationship or a partitive relationship, or partitive is whole to part and generic is like thing to type of thing. And so now I'm achieving a little bit more precision with my knowledge graph because I have those relationships modeled in a way that indicates what type of relationship it is. Is it a generic relationship or a partitive relationship? Here's the properties that are being included: a definition, definition source, the type, the usage, the gender, the context citation, and a note. So now most of the content, the majority, I haven't included the status from the LocTerms data model just because I need to think about very carefully about how the status of a concept entry or term entry and the need to revisit concept nodes and term nodes within the knowledge graph would be approached because language is evolving all the time. So that's the thing about terminology work. If you create a term base and then you just let the term base sit for 3, 5, 10 years, technology is evolving so quickly that you're going to end up with an obsolete resource that doesn't reflect the reality of how terminology is used. So this is the overall model. there's an SCG file that you can access to see this picture in greater detail. But this is essentially the model that I'm working from. It may not be exactly what's represented in this paper, but it's close enough for our purposes here. When we're thinking about the knowledge graph in the Neo4j environments, I've already started to show this a little bit where we've got nodes that I've added one by one. That would be a recommendation that I would make, that when you're first getting started, is that you sort of add the nodes one by one, because there are definitely aspects of my relationship model that changed, aspects of how I named the relationship types that changed a little bit once I started to work, because I just found out that the way I was naming things wasn't precise enough. I guess other issues I ran into when I was first adding nodes to my knowledge graph is that the properties as well, the capitalization of properties, was something that I wasn't quite getting right. It took me a while to get the term label lowercase and the concept label uppercase. I started over quite a few times. Next, if I wanted to import data into, because obviously if you're creating a knowledge graph within a knowledge graphing system, you don't want to be going through and adding your nodes one by one. That's not scalable at all. And so the next thing that you'd want to learn how to do is to import data. First of all, you need a really good, good data structure. So we're taking the database here that I exported from SmartCat, a translation environment, and now I want to import it into the Neo4j environment. So I've reconfigured the data so that it facilitates import. In order to import data, I can add a node label. I'm going to give this one the label concept. Let's add another node label. Let's see. I'm going to add this one. It's going to be called term. Let's get a relationship going by, I guess you do this. Relationship type, reverse direction. Let's reverse the relationship type because we want the term to be is, designation for. Okay, so I imported one page from this database. I imported this page terms en. Now what I'm going to do in the workspace in order to do, now that I've got my model drawn, I'm going to select the file that I'm going to get this information from. I'm going to map my properties from the file. So I'm going to include, we'll have the term, the usage, the type, the context citation, and the notes. These are relationships, so I'm not going to add these. No, I want to name this designation. This is going to be my main, my unique identifier, so I'm pressing the lock. I actually want all of these to be lowercase, so I'm going to just go through and lowercase these. I want to rename this property to context _1. I want to rename this property to citation _ context 1. I'm including ones because just in case I want to add additional contexts, then the next context would be context 2 with citation context 2. Same with a note. This one I don't want. And so now, based on this structure here, I can import the term data. For my designation, I'm going to map this from, again, this file. The term is going to be the term, and then the is designation for concept. So now I'm saying, okay, where is the term information and the concept information coming from? Let me add my concept one too, because maybe that would be interesting to have my English concepts all in here too. So I'm going to download a CSV file. There's a bunch of different ways to import content into Neo4j as well. I'm just getting started using the SCV file. This is kind of recommended for when you're in pilot mode, when you're getting, used to the system. So now I'm going to pick that second file. Again, map my properties from the file. I want the concept, I want the definition citation, the note. These are relationship fields. So I'm not going to add these ones here. And I'm going to make this my key. Again, I want to do some adjustments to the property labels that are going to show up within the field. So I'm just going to go definition _1. I don't know necessarily that we would need multiple definitions, because typically within a term base, the best practice is to include only a single definition, because we're essentially naming the superordinate concept and then the delimiting characteristics for an intentional definition of a generic relationship. But I'm getting my definitions at this point from research papers and things like that. And so I might include multiple definitions in my entry, or I could take the definitions and put them to the context. I don't really want to do that yet. I can reconfigure these things later on. So, okay, so now let's run the import. And let's go over and see our results. If we got some new results here. We did. I don't know why this is the verb. I know why. This should have been name. I should have imported the concept under name. But as you can see, the data imported, I think you kind of get the point. I'll have to go through and clean this up later on. In fact, I'll probably go to my homepage and completely clear this instance and redo the import process so that I get a clean import. But I think this is sufficient for the purposes of this discussion. So conclusions that I'd like to make about this entire process. First of all, as we just saw, we're going to be working with databases a lot. Terminology work takes databases and configuring databases this way and that way so that they can be imported into different systems. Of course, when we get farther along with our terminology work, we'll have a single source of truth with APIs that are connecting that single source of truth to various systems where whatever data is being modeled in the single source of truth is being mapped onto the target systems. But all of this requires an understanding of how data is modeled in the various systems too. So even if the goal is to reach that point, you're not going to reach that point without understanding the fundamentals of how to model the data and what the data looks like in something as simple as a database. Additional challenges that are a part of doing the conversion of term bases to knowledge graphs include naming concepts, as we talked about, or differentiating between concepts and terms, understanding that we only have language to talk about all of these things, thinking about how we're going to model things like languages and subject fields. Should those be labels? Should those be properties? Should those be nodes? To avoid duplication, taking things that are replicated often and moving them into a node is what I learned from Neo4j is a best practice. Some of the opportunities that we saw when it comes to knowledge graphing is that we can be more precise about our concept relationships using is type of, is part of, to denote different types of concept relationships, generic or partitive. We also saw that there's less duplication here because in a term base, I would collect subordinate and superordinate concepts at the concept level of every concept entry. And here it's just collected in a single relationship. We saw that additional opportunities would be adding information about the audience so that we're aiding the generative AI applications in deciding what is the best term given the audience. And a huge opportunity that I'm really excited about is moving away from this one-size-fits-all approach of concept mapping, where, as I discussed in quite a bit of detail earlier, Termbases, they assume that every single language follows the same conceptual structure, which is just not how it works. Every language is built off of the unique needs of that culture from which it's derived. And so rather than forcing conceptual structures of one language onto another, we have an opportunity with knowledge graphs to let each language map concepts according to how they are mapped in that system, and then linking together concepts that truly have like a 99% degree of correspondence. Big picture step in knowledge graphing is integrating a knowledge graph into natural language processing tasks to improve the accuracy of content generation and translation. So we're going to learn about the particulars of that in the next installment of the Terminology and GAI series. Thanks so much for listening, and I hope you have a great day.